Hello my dear children, this is class 11th, chapter is structure of atom or atomic structure going on. Now your topic next is discovery of proton. Now students, in my last lecture we discussed the discovery of electron in a J.J. Thomson cathode ray experiment, right? Now students, actually the Goldstein idea, write down the name of the scientist, Goldstein. Idea came in the mind of Goldstein that atom is neutral. Atom is neutral. If in the atom there is something negative, then the positive must be there because the atom is neutral. That's the reason Goldstein repeated the discharge tube experiment. Okay? If the atom carry negatively charged particle, then atom must have something positive. Let us repeat the experiment. Same discharge tube, same it's a vacuum pump, okay, same hydrogen gas. Just one thing changed. Goldstein took a cathode with holes, little holes. You call it perforated cathodes. It's your anode. Anode, it is backside, you can mark it like this. This is your anode, backside same, ZNS chemical, even backside this also today, ZNS chemical. Gas filled is of hydrogen. Very interesting experiment it is. Just one little thing changed. That is, he took perforated cathode. Write down. Perforated means holes. Cathode with little holes. Perforated cathode. He took a cathode with little holes, right? Now he repeated the experiment, same. He passed the electric current 10,000 voltage about at a very high voltage. When the electric current passed at a very high pressure, nothing observed because there is no way to move something at very high pressure. When the pressure somewhat released, then the gases started conducting electricity, streaks of light visible. That topic we have done in the last lecture. Now students, listen to me carefully. This today's experiment, not only this side ray is visible, a new kind of ray appears, the back side of the cathode also. Write down. This is back side of the cathode. Scientist Goldstein repeated the experiment. Just he took a perforated cathode with holes and he observed one thing new, that is a rays at the back side of the cathode. These are the streaks of light that we called just today cathode rays, which are made up of electrons, how they produce, everything I discussed. I will repeating everything today even. So these new kind of rays, these are called canal rays because it passes through the holes, CANAL, and after that some more names we will give sooner. First of all, let us understand how these rays come out this side. So I'm taking in detail. Same experiment, just this side. And this same, this ZNS chemical started glowing this side, even this side. Because these rays struck, and these rays also struck. When these cathode rays struck to ZNS screen, a fluorescence produced, glowing of light, and this chemical also started glowing this side as well. Let us, I'm going to explain all these things. Now students, this is my cathode, perforated cathode, right, with holes. It is your negative side, cathode it is. And this is your hydrogen gas. Hydrogen gas is made up of hydrogen molecule, which is further made up of atoms. Okay? So these are the hydrogen atoms. So I'm going to draw a few of the atoms. These are all H atoms, right? Now I'm going to repeat topic of the previous one. Electric current passed. Electric current struck the H atom. When they struck the H atom, they knocked out same, that is same particle as it was present in electricity, same, it knocked out some negative particles from this atom and moved towards the positive side, positive electrode. When the electric current passed through this, it knocked out something negative from it. Then this atom, which is a neutral, if some negative particle is extracted out, then it becomes a positively charged ion. Make it, all these become positively charged ion. All because electricity knocked out some negative thing from it. So all these become positively charged ion. Opposite charges attract each other. This is your negative electron. Now these positively charged ion started moving this side. All these positively charged ion started moving this side. But some of the positively charged ion get collided with the, you can write collision. A collision takes place. It gets collided with the negative particle of the electricity, that is electron, and get neutralized. But some of the positively charged ion escape, E-S-C-A-P-A, escape. In what way they escape? By the process of neutralization, because they are in front of the holes, and those were in front of the holes, there were not any cathode ray coming, so they escape and passes through these holes. Make it like me. So some of the positively charged ion escape, they passes through these holes, and these are the positively charged ions. These positively charged ions are called anode rays. So what are anode rays? Anode rays are made up of positively charged ion, which is known as protons. So all these are the proton. Anode rays are made up of protons. Cathode rays are made up of electron. Cathode ray originated from cathode, but anode ray never originated from anodes. You can see anode is so much far away. From where anode ray originated? Anode ray are originated in the space between cathode and anode. They are just positively charged ion. Those escape from the process of neutralization. Now again listen to me carefully. Now see, again you see my hand. This is my hand. These are the some of the holes. This is a perforated cathode. These are the holes. Okay. So these are the positively charged ion. So these are the positively charged ion. Some of the positively charged ion struck to this my finger. Those struck to this my finger, they again pushed back, and some of the positively charged escape, and they come towards this side. But those positively charged ion which struck to this material of the cathode, they are not able to pass out. Okay, some escape. So these are the positively charged ion traveling. So this is a perforated cathode with the holes, right? Now, so what are anode rays? Anode rays never originated from cathode. Again, this is your perforated cathode. Highly speeded current, that is, this is your cathode, negative, 10,000 voltage. Last time I was explaining, this is your electricity, which is itself made up of small particles called electrons. Okay, so when these come through this material with a very high speed, they struck with the H atom. Make it H atom. When they struck with the H atom, it knock out, it take out, extracted, let it say electron present inside, same as it was present in, that's electricity. This is your electric current coming, and when it struck the H atom, it knock out electron from inside, and then it become positively charged ion. Positively charged ion. So these positively charged ion, in this way they go back. Some of get neutralized, but some of the positively charged ion escape and this is your anode ray. So now you can write questions from your side. What is the difference between cathode ray and anode ray? Student, all the properties of cathode ray, anode ray are same. Just two properties differ. You may write that it is an anode rays, passes through the electric field, deflected towards the negative plates. So they are sure they are made up of positively charged particle called proton. Proton it is. Okay. So only one. If it is a cathode ray, then surely they will deflect it towards positive plate. But today we are discussing anode ray. Same properties, anode ray travel in a straight line. Anode rays deflected towards negative plate. Cathode rays deflected towards positive plate. Both destroy ZNS screen. Both affected, that is photographic plates. The one, this property different, and other is about E upon M. Write on E upon M. E for charge and M for mass. Charge upon mass ratio is different. In cathode ray it is always same. Whatever the gas, E, write down E upon M ratio never changed of cathode rays. But E upon M, that is charge upon mass ratio, always changed in anode rays. It depends upon the nature of the gas. Now you know there is two differences between cathode ray and anode ray. One cathode ray is made up of negative, deflected towards positive plate. Anode rays are made up of positively ions, deflected towards negative plate. The second is about E by M. E by M is 1.76 into 10 to the power 8. It is coulombs charge unit per gram, and this is experimented by scientist J.J. Thomson. Write down J.J. Thomson experiment about E by M ratio. E by M ratio experimented by J.J. Thomson. It is fixed. It is fixed, whatever the gas inside the discharge tube. But in anode ray for hydrogen it is 9.58 into 10 to the power 4 for hydrogen gas it is. The moment you change the gas, it will change. E by M ratio changes of anode rays. It depends upon the nature of the gas. So this is E upon M, and about the charge. Charge is calculated by Milkian's oil drop experiment. Milkian's oil drop experiment. There is a charge E for charge. Both have the same charge, 1.6 you may write, into 10 to the power minus 19 coulombs. It's negative for electron and positive for proton. Same charge, 1 unit, it's called 1 unit charge. So mass, we can calculate the mass. If you want to calculate the mass of electron, you can write mass of electron. What you will do? E upon M by E. So you can calculate, or either you apply the formula charge of electron, that is E, and charge upon mass ratio of cathode rays, that is E upon E by M. E cancel, your M will come on the upper side, that is called. Now this is your mass. Now what is your charge of electron? 1.6 into 10 to the power minus 19 coulombs. And what is about E by M? 1.76 into 10 to the power 8 coulombs per gram. Coulombs cancel, your answer will come 9.1 into 10 to the power minus 27 gram, or 9.1 into 10 to the power minus 31 kilogram. You please remember, it's a mass of electron. Electron mass is very much negligible. 10 to the power minus 31 kg is very lesser mass. It's almost negligible. So if anybody asks you what is electron, you may write definition of electron. Electron is a fundamental particle of the atom. Electron is fundamental particle of the atom which has charge 1.6 into 10 to the power minus 19 coulomb, and charge is this, and the mass is this, 9.1 into 10 to the power minus 31 kg. And mass of the electron is 1 upon 1837 part of H atom. Again listen, how to calculate E upon M. E upon M calculated by Thomson, charge of electron proton calculated by Milkians. It comes fixed 1.6 into minus 19, and charge upon mass ratio of cathode ray is fixed 1.76. We applied the formula E upon E by M, E cancel, M comes, this is mass of electron, and the mass of electron is too much less, it is almost negligible, and electron, write down, electron is 1 upon 1837, or you can write 1 upon 1840 part of H atom. Write down mass of proton. Same formula you will apply. Mass of proton, it is equal to, again same thing, charge of proton. Charge of proton, that is again same 1.6 into 10 to the power minus 19 coulombs upon charge upon mass ratio of anode rays, that is 9.58 into 10 to the power 4 coulombs per gram. Coulombs cancel, your answer becomes 1.673 into 10 to the power minus 24 gram, or 1.673 into 10 to the power minus 27 kilogram. And this mass is exactly the same, remember, as a mass of a single H atom. Proton mass is exactly the same as a mass of H atom. So remember, this is, now this is your, now make a table. It will be, by making a table, it will be very easy for you to learn all things. Make a table, write down electron, write down proton, okay? Charge is 1.6 into 10 to the power minus 19 coulombs, same. It's a negative, it's positive. 1 unit negative charge, 1 unit positive charge. And what about, write down charge, write down mass. Mass is 9.1 into 10 to the power minus 31 kilogram, 1.673 into 10 to the power minus 27 kilogram, about proton. Okay, last is E upon M ratio. E upon M ratio, no need just to write, no need in this boxes, just to write. This is very much important. If anybody asks you a question, what is electron? You can say electron is fundamental particle of atom which has 1 unit negative charge, that is 1.6 into 10 to the power minus 19 coulomb, and the mass is 9.1 into 10 to the power minus 31 kg, and electron is, remember, electron is exactly 1 upon 837 part of H atom, hydrogen atom, so small it is. And what is a proton? Proton is another fundamental particle of atom which is charge 1 unit positive charge, that is 1.6 into 10 to the minus 19 coulomb, and the mass is exactly the same as the mass of a single atom of hydrogen atom, 1.673 into 10 to the power minus 27 kilogram. There is a one question, make a, you may write, before taking question, just I am writing E upon M ratio of electron of cathode ray is 1.76 into 10 to the power 8 coulombs per gram. E upon M ratio of anode ray, which will change with the change of the gas, and for hydrogen it is 9.58 into 10 to the power 4 coulombs per gram. Write down for hydrogen gas only. It is for everyone. E upon M ratio, charge upon mass ratio. Write down one of the questions. This is the last line of my lecture. Show that electron is 1 upon 1837 part of H atom. Question number 1. Show that electron is 1 upon 1837 part of H atom. Or show that electron is same 1 upon 1837. That is, you may reverse this question. Show that your hydrogen atom mass is 1817 times more than electron. 1817 times more than electron. Students, what you will do? You divide the two masses. Mass of electron divided by mass of H atom. Mass of electron is 9.1 into 10 to the power minus 31 kg. And which is mass of H atom is 1.673 into 10 to the power minus 27 kilogram. You divide the mass of electron by mass of H atom, Electron mass is 9.1 into minus 31 kilogram. Hydrogen atom mass is the same as the mass of proton. So it's 1.673 into 10 to the minus 27 kilogram. This will cancel, and after calculation your answer will come. You can write separately. Your answer will come 1 upon, that is called 1 upon 1837. So your answer come mass of H atom is equal to 1837 into mass of electron. Mass of electron. Okay, mass of electron divided by mass of H atom. So it's a very beautiful question. You can attempt this question in many ways. So this is all about today's lecture, and after that the next mass, that is discovery of neutron, we will take in the next lecture. Thank you.